This is William Willits, and I'm going to take you through a SQL injection tutorial. This is a project that I created for the midterm component of CS 6056 at University of Cincinnati, spring 2018 semester, for Professor Franco. I'm an IS person, and so I've done a lot with data and databases, and also have a background in web development, so I chose this project as kind of a synthesis of those areas. And what I did was create a website here that uses HTML and PHP, and it's connected to a MySQL database that I created in PHP MyAdmin. And this database has all the page data, all the content, and also a user table and a test drop table. So you can see the page table here has an ID, and it has the content, the HTML content of each page. The test drop table just has dummy data. It's just a table that we're going to play with to try to drop a table with SQL injection. And the user table has ID and password information and some other user information that we'll use to simulate an attack against, getting sensitive data from a website through SQL injection. Just to look at the code a little bit, this here's the index.php file. This generates all the pages from the database. So I have a connect query up in the top, and then here, this is where we pull the content into the content div. And the way that we do that, just to show you when I go to different pages, you can look, there's a URL parameter up here that changes. These links pass a different parameter into the URL, and that parameter is passed to the database, and that's actually the ID field of the page ID. So when that page ID is 1, we're going to have display this content, and so on. So I have a select statement hard-coded, and that just joins to the HTTP GET request, which pulls that parameter of page off of the URL. Which isn't the best way to do things, but I wanted to do this in a sloppy way so that I can illustrate SQL injection. Then I have this query gets run, and the content row is displayed. One other side note before we get started, I'm using the MySQL I multi-query function to query the database, and that's kind of not standard. Normally you would just use a query function, but MySQL doesn't allow for multi-queries, which is a common technique of SQL injection, and it's something that's possible with other database platforms such as Microsoft SQL or Oracle or PostgreSQL. So I wanted to be able to illustrate that. But under normal circumstances, if you're dealing with a MySQL database, you wouldn't be able to do multi-queries unless the code was using this special multi-query function. So to get over to the tutorial, first, when you find a website that you think may be vulnerable to SQL injection, you need to gather some information. And the first thing you can do is search the URL for parameters that change based on page data. And if you see that, such as here, that's a sign that there's a parameter that's going to be tied to a SQL statement behind the scenes. And that's a good sign that it could be vulnerable to injection. Once you do that, you want to perform some logical tests on that parameter to see if that parameter is vulnerable to modification. So what I have here are 3 different options for logical tests. There are more, and different ones will work with different databases and different versions within those databases. But oftentimes what happens is you add a logical operator to the parameter, which means, like in this case, the page needs to be equal to 1 and 1 is equal to 1. So obviously that's always going to be true. And we can try this. When I attach that to the URL, nothing happens. Everything still displays, no problem, because 1 is equal to 1, right? Now if I change that and say, and 1 is equal to 2, this is not the case. This is going to return false. And when I plug that in, the content's gone. So right there, that proves that this is vulnerable. I can add syntax or add to the SQL statement in ways that will modify what happens. So once we can do that, we need to find out how many columns are in the table. And that's going to be the table that is being acted upon here, the page table. And the way that we do that is using the order by. So we just start with order by 1. And we're going to need to keep incrementing this up until we reach a point when we hit an error. So 1, 2, and 3 are fine. But when I get to order by 4, the content disappears. Now, the reason that is because if we look at this table, there are 1, 2, 3 columns in the table. There's the ID, the content, and meta. Now, that's why it works fine if you're ordering by 1, 2, or 3. But if you're going to order by 4, it's going to break because there isn't 4 columns to order by. So you can perform this test on anytime you find an executable parameter that can be executed in SQL. You can use this to determine how many columns you're dealing with. And that's useful for the next step. So we found out that there's 3 columns. Now we need to find out which columns are editable. And the way that we do this is we use the union. Well, first of all, we change the page parameter to some number that actually isn't attached to anything. And that's just going to get rid of all this content so that we don't have all this garbage here. And then we're going to union that with a select statement of the first 3 columns from information schema.tables. An information schema is a construct that MySQL databases come with built in, and it's kind of an index of the tables. So what this is going to do, whoa, something's weird here, is it? No. What this is going to do is it's going to try to select all 3 columns, right? But the problem is, if we look at the SQL, the return here, we're only returning the content column. So we're not going to return the ID column or the meta column. And so 2 is the only thing that's displayed. That's this 2. That tells us that 2 is the column that we can actually use to display things. So that's the next step. And you'll see in the next step how that's used. So we could use that to check the version of this database. And the way that we would do that is to use the same union select statement, but we're going to replace the number 2 with this tag at version. And this is only good in MySQL, but what we're doing is we're passing this parameter into that second column, which is a column that we can actually act upon here. And you see what comes out? It shows us the version of MySQL that's being used here, 5.5.59. Moving on, we can use the same idea to figure out the names of every table in the database. Now, what's happening here is we have a union, select 1, and then in the 2 placeholder, we're putting table name from information schema.tables. So this is going to give us all the table names. And you can see here we have this big long string. Things like global variable, key column, or key column usage parameters. It'd take a little trial and error to figure out what all these are, but really we don't need these all caps ones because these are automatically created when you start a MySQL database. At the very end, we're going to see the user tables that I created. The page table, test drop, and user that I showed you at the beginning. More often than not, these are the ones that are going to be interesting to somebody who's trying to retrieve data with SQL injection. So we've just figured out the names of our tables, which is, now we're getting to some interesting things. So once we figure that out, we have to pick a table to try to probe further at. And, you know, like a malicious person may decide to probe at the user table, let's try that. So what we do now is we are going to modify that statement that we used, you know, in the last few steps. We're going to, instead of displaying table names, we're going to display column names. And instead of displaying the table names from information schema.tables, we're going to display the column names from information schema.columns. But we only want to display the columns where the table name equals user. So this user is information that we learned in the previous step. And here we go. ID, PWD, fname, lname, email, age. If we look over at the user table, oh, darn it. Apologies. This times out periodically. It will only take me a second. Okay, ID, PWD, fname, lname, email, age. There you have it. So now we know all the table names and all the column names of any tables we're interested in. We have all the information we need to start pulling actual data at this time. That takes us to part 2. So in part 2, we're going to start pulling actual rows out of the database. Or maybe not rows, but we're going to pull columns. We're going to pull the actual contents of the database rather than just learn about the structure of the database. And the first thing that we might do is keep using that union select style of attack. And we can now select the ID, which is a column that we discovered in the last step, from user, which is the name of a table that we discovered in the step before that. So we're building on each step here. And here you go. JRocket, Nerdo321, RBird, 2Guns, 000. And if you look, there you have the IDs. We just displayed those. If we want to display the passwords, we just replace that with PWD. There's our passwords. And so on. We could put any column we want and display them. If we want to format this in a nice way, we can do that. If instead of just putting a column field in the to placeholder, we can use the concat function to concatenate strings with columns. And here I'm displaying 2 columns, user ID and password, and I'm giving them each a title as well. User JRocket, password Johnny123. Let's try it. Oh, there you have it. It gives his information, Johnny Rocket, age 32. Pretty cool. So, we're getting to some useful information here. Attacking a login form. Now, for this next one, we're going to actually do a little bit more with that login that I just showed you a second ago with Johnny Rocket. Just to show you that when you have a user input like this, it can be just as vulnerable as when you're using a URL. And you could actually use a lot of those techniques with the union selects down here as well. I'm not going to go through them all again. Instead, I'm going to show you another style of attack. This goes back to using that logical operator. And what we can do here is we're using the OR, 1 equals 1. And we put that same thing in both the username and password field. Now that single quote at the beginning, what that does is it closes the first part of that where clause. So it's a select all from the user table where ID equals whatever gets put in here, right? That's closing that. So the ID is going to come up blank. But that doesn't matter because then we have OR 1 equals 1. And this last one's not closed because it's going to be closed once this gets passed into the SQL statement. But it doesn't matter that the first part comes up false because 1's always equal to 1 on both of these cases. So when I click submit, it's going to display the name, email, age of every entry in that database. Now this doesn't display the username and password. We did that with the union select a minute ago. But this displays whatever is echoed from that while statement that iterates through the result set of the SQL statement. So in this case, it's going to be name, email, and age. Pretty cool. Now, finally, I have one more thing to show you. The batch statements. Now, this goes back to what I mentioned at the beginning and why I'm using a multi-query, because I wanted to show you a batch statement. All a batch statement is you add a semicolon, which ends one SQL statement, and then you add another one. Drop table, test drop. This is a simple drop table statement. We've researched that test drop is a table name that we figured out in part 1, and we can drop that table if we want. We could drop any table we want. We could also create a table. We could also add records to a table, delete records, delete columns, whatever we possibly could want to do in terms of erasing, adding, or modifying data. We can do if it's going to allow us to do batched statements. So let's go ahead and paste this in. But before I hit enter, I just want to show you that test drop is there. It does exist. Now we drop the table and reload. Test drop is gone. So the drop table worked. You can't tell, you get no feedback on the front end here that the table was dropped. But it obviously was dropped. If I dropped the table page, you would know because all of this information would instantly be gone. Of course, I'm not going to do that. And hopefully nobody else does that while I have this site live. I will be taking this site down as soon as this video is public because I don't want people coming and messing with it. So that gives you a good tutorial about how to perform basic SQL injection and some of the basic techniques. Now, I just wanted to talk for a minute at the end how to prepare against or protect against SQL injection. There are basically two ways that it's done. One solution is to use what's called magic quotes, and this is something that was used a lot more a couple years ago. It's been deprecated in the most recent versions of PHP, so there are probably a handful of, probably a good amount of PHP implementations running out there that are using older versions, and they may be using magic quotes. Magic quotes is a global setting in which PHP searches input strings for special characters such as quotes, semicolons, commas, I don't know, things like that. I'm not sure if commas is one, but special characters that are oftentimes used in SQL injection and in other types of, malicious things. And it adds a backslash before those characters, which escapes them out, and it makes them useless in terms of it tells MySQL that those characters are part of this input string, not part of the code statement. So it works to a certain degree, but there are ways around it. You can input ASCII codes or hex codes, or there are other methods too where you can get around the magic quotes function. So it's really not advised. Also, since it's deprecated, it's not portable. If you're relying on magic quotes and you decide to update your PHP, all of a sudden you're going to be vulnerable because magic quotes will be gone. And finally, the other reason that it's a bad idea is that it makes your data messy. If you have all this user inputted data that has special characters, you're also then going to have backslashes all over the place throughout your database. And whenever you make use of that data again in the future, you're going to have to deal with those backslashes. So you're just really kicking the can down the road. If you get rid of the backslashes, then again, you're going to be having a possibly malicious code in your database. So really, it's not a good way to handle it. And PHP actually has a section of their documentation now where they more or less apologize for ever making magic quotes a thing. They say it was a mistake and it's not the right way to handle it. So, one of the bad points of PHP there, the language has some weaknesses, and the magic quotes was one of them. I apologize for the dog. So the proper solution is really to use prepared statements. And that basically means that you're going to use this function called prepare, which comes in the more recent versions of MySQL. And what you do is you create a stock SQL string that doesn't directly concatenate with an input. Apologies, my dog's going crazy. It doesn't concatenate with the HTTP GET or POST request directly. Instead, you have a question mark placeholder parameter. And then you can bind that question mark to a certain data type and connect other variables to it without actually integrating them. So what ends up happening is you have this select statement or whatever type of SQL statement you want with a parameter bound inside of it that won't be allowed to act on the actual SQL statement itself. As we've seen, most of these examples, we're just adding to the end of the SQL string to change the functionality, right? And the prepared statement really makes it so it's very close to impossible to do this. You never want to say totally impossible because probably somebody's come up with workarounds, but it's very difficult. And it's also just a more efficient way to run statements in general if you're going to be running a lot of them, or if you're going to have a lot of action on your database. So those are the main protections. We went through how to gather information, how to retrieve actual data from the tables, and how a good programmer should protect against these vulnerabilities. If you're interested in learning more, visit the references or just Google search. There's tons of information out there. And if you're still listening, thanks for making it this far. I appreciate it. Have a good one.